Students, welcome back. We are given this question, integral 0 to pi over 4 sine 2x dx divided by sine raised to the power 4x positive cos raised to the power 4x. We should be able to show this is equal to pi over 4. So consider the left hand side. So we have got integral 0 to pi over 4 sine 2x dx divided by sine to the power 4x positive cos to the power 4x. Now I'm going to rewrite this as integral 0 to pi over 4 sine 2x divided by sine squared x positive cos squared x raised to the power 2 times dx. So when you have sine squared x positive cos squared x raised to the power 2, if you were to expand this, you would get sine to the power 4x positive cos to the power 4x positive 2 times sine squared x cos squared x. So there is an additional 2 times sine squared x cos squared x. And you have to remove that. So that's going to be negative 2 times sine squared x times cos squared x. Now clearly sine squared x positive cos squared x will give you 1. So that's going to be integral 0 to pi over 4 sine 2x dx divided by 1 negative 2 times sine squared x cos squared x. Now I'm going to rewrite this as integral 0 to pi over 4 sine 2x divided by 1 negative. So I would be using sine x cos x and then I would be raising them to the power of 2. So when I do that, I have a 2 here, so let me place the 2 there. If I were to raise them to the power of 2, this is going to be 2 sine x cos x raised to the power 2. So that would give me 4 times sine squared x cos squared x. Okay, but I don't have the 4 there, right? I don't have the 4 there. I only have the 2 there. So I need to do something to remove that 4 and have the 2. So that can be achieved by multiplying with 1 over 2. So now I have a formula. The formula is 2 times sine x cos x is sine 2x. So by this formula, I can now rewrite this quantity to be integral 0 to pi over 4 sine 2x divided by 1 negative 1 over 2 times sine 2x raised to the power 2. Now this can again be rewritten as integral 0 to pi over 4. See, I got a 1 over 2, so that means this is going to be 2 negative sine 2x raised to the power 2 would give me sine squared 2x, with 2 being in the denominator. So you also have sine 2x in the numerator. So I've got something like this. Now if I were to move this 2 to the numerator, so this would give me 2 times sine 2x divided by 2 times negative sine squared 2x times dx. Now you would have studied this formula, which is sine squared x is equal to 1 negative cos squared x. So that means sine squared 2x would be equal to 1 negative cos squared 2x. So this can be replaced. So replacing it, I would now have integral 0 to pi over 4 2 times sine 2x divided by 2 negative 1 negative cos squared 2x times dx. So this is equal to integral 0 to pi over 4 2 times sine 2x divided by 2 negative 1 positive cos squared 2x times dx. Now 2 negative 1, this can be clubbed together, and that would in turn be equal to 2 times integral 0 to pi over 4 sine 2x divided by 1 positive cos squared 2x times dx. So now what I need to do, I need to make the substitution. So the substitution would be, let u be equal to cos 2x. So when I differentiate du, I get sine 2x, the coefficient of x is 2 with the negative sign times dx. So this is what I have got. Now in the integrand, I can just substitute these values. So that would be integral. In the place of sine 2x, I would have to substitute it with du divided by 2 with a negative sign would be equal to sine 2x dx. So when we make that substitution, I would have du 1 over 2, I can move it out, and that has to be divided by 1 positive cos 2x is u, so it's going to be 1 positive u squared. Of course, I have a negative sign and 2 there. Okay, so clearly, let me box this substitution. The 2 which you see in the numerator can be cancelled with the 1 in the denominator, giving me integral du divided by 1 positive u squared with a negative sign. I have not done anything with the limits. The limits are 0 to pi over 4. So let us handle the limits now. So when x is equal to 0, what happens? U becomes equal to cos of 2 times 0, which is cos 0, which is equal to 1. So when x is equal to 0, the value of u is 1. Now next, when x is equal to pi divided by 4, so what happens to u? U is equal to cos of 2 times pi divided by 4, which is equal to cos pi over 2, which is equal to 0. So in this case, u will be equal to 0. So we got the two limits, which I'm placing it here. Now substituting the limits are in the place of 0, it is going to be 1. In the place of pi over 4, it's going to be 0. So 1 and 0. Now you would have also studied an important formula, which is integral dx divided by x squared positive a squared is 1 over a tan inverse of x divided by a positive constant c. I would be applying the same formula here. If I were to apply that formula, this is equal to 1 over a is just 1 over 1. Of course, there is a negative sign. Now tan inverse of u divided by 1, the limits are 1 to 0. So this is rewritten as negative 1 times tan inverse of, substitute the upper limit 0, following it up with the substitution of the lower limit, which is equal to negative, this is going to get cancelled, tan inverse of 0 would be cancelled, and you got negative 1 of negative, tan inverse of 1 is going to be pi over 4. So negative negative is positive, giving you positive pi over 4, which is the right hand side.